Hi class, let's take a look at example 2. And first, let's try to determine what type of test we're going to be actually evaluating. Now, notice that we're actually told on the second sentence that the standard deviation of all salaries is, 463, 364. So in this case, the values of sigma is given. We're given that this is 463,000 and 364. So let me box that up, because what that's going to indicate is that this is going to be a z-test. Let's also look at the information of the sample, so the one that we're comparing. So our sample has a total of 40 salaries, and they contain a mean of 415,953. So this is the sample that we're looking at, and let's take a look at the claim. So the claim is that the mean of all salaries is less than 500,000. So in this case, it's going to be a left-tail test as we look at the actual population. So let me start with the claim. So in this case, our actual claim is that mu, it's less than the 500,000. Now HO and HA. So technically we can rewrite it in the following format. The values of HO, mu is equal to the 500,000, and then your HA, mu is less than the 500,000. Now, because I mentioned a less than, it's actually going to follow the actual, the general setup is on page 1, which means it's one of these less than, and it's actually going to follow, well, this particular sketch. That's the value of alpha for the population. So we're looking at, let me erase this, we don't need it. We're looking at these two actual scenarios. So let's take a look now at the actual critical values. Now, remember that when you're looking at the critical values, you're actually looking at the actual population. So we're given that, and this is actually here. I'm looking for the value of alpha. So in this case, your value of alpha is equal to 0.10. That means that C is equal to 0.90. Now, as we look at the actual population, we assume that your population is bell-shaped. And in this case, because we're dealing with a left-tail test, alpha is on the left. So the shaded region, it's going to be on the left. And this is going to be a C-score. To find the C-score, let me give you the code. This will be second distribution. And then you're going to be activating the inverse norm. The area to the left is 0.10. And technically 0 and 1, since we're looking at the actual, well, at the actual distribution. So this is going to be, we're looking at negative 1.28. Now, when we look at the actual sample, and in this case, the test statistic, we're going to be looking to see where it lands. If the test statistic lands here, automatically show. If it lands on the non-shaded region, you would just simply fail to reject HO as your main conclusion. So take a second and let's actually do the calculation for the test statistic. Now, as we do the calculation of the test statistic, we're looking at the sample. So in this case, test statistic So it's going to be a z-value of x bar minus mu divided by sigma over the square root of n. So this is going to be the mean of the sample. It's 415. So 415. 953 minus the mean of the sample. This will be the 500,000 over the standard deviation of the sample. So 463. So 364 over the square root of, in this case, 40. So please evaluate that and see if we're matching. And see if you're matching to approximately negative 1.15, rounding to a total of technically 2 decimal places. There's more values in the calculator, but that's what I'm getting. Now, for our final answer, you're gonna technically look at where does this actually land on the number line. If it's to the left of negative 1.28, you're gonna reject HO. If it's to the right of it, you're gonna fail to reject HO. In this particular reason, it happens to be to the right of it. So your final conclusion, it's gonna actually say the following. So let's actually write this one with the notation that you may have to look in some of the homework problems. So you would simply say, fail to reject HO, and then let me show you the proper wording. So for this particular one, if you look at the problem, the original claim, it's a less than. So you're going to have, does your claim contain equality? It's going to be a no. And then do you reject? No, we ended up failing to reject HO. So then your proper wording, it's going to be in this format. There is not sufficient sample evidence. So let me write it here. Fail to reject HO. And then say, so we're looking at there is not sufficient sample evidence and then we're actually adding to support the claim that, and the claim is that, well, mu, it's less than the 500,000 at, well, C is equal to 0.10, since technically your values of C is equal to 0.10, since alpha is equal, C is equal to 0.90, since the values of alpha is equal to 0.10. So at the level of confidence of 0.90. So that's going to be our main conclusion. Some of the problems in the book are actually going to want you to follow the chart that's actually here in order for you to basically finish the problems. Your solutions are going to end up with a pull-up menu that you have to follow this chart. Now, let me show you how to actually run this problem with the calculator. So you're going to be running stats, and then the type of test, it's going to be a z-test. And then make sure you punch in all the information. Let me double check. 500,000, 463, 364, 415, 490, 415, 953, And in sample of 40, it's technically a claim less than, so it's going to be a left tail test. And let me calculate. Now, the test statistic is here. So, except that I rounded on the calculator as I was evaluating this portion. So that's going to be the negative 1.15 rounding to 2 decimal places. On the good news, this test will give you the p-value. That's actually problem B. So it'll be sufficient to say that the p-value, it's approximately, and in this case, 1257. Now, when we're looking at the p-value, in this case, you're looking at the actual sample. So your sample is going to look as follows. It's going to be a bell-shaped curve. Your claim is less than, so your test statistic ended up being a c-value of approximately negative 1.15. We're looking at this value that was calculated there. And your p-value represents the area or the critical region, but of the actual sample. So in this case, that's going to be the area to the left of the test statistic. And in essence, what we're doing is we're actually comparing the shape of the actual population to the shape of the sample to see if they're about the same or if they appear to be both from a technically bell-shaped curve that has a mu less than 500,000. So in this case, failed to reject HO. Failed to reject HO means that we do not have sufficient evidence that mu is less than this one. So failed to reject HO means this is correct. We don't have evidence of this portion here.